All right, so today we're digging into this research paper. It's by Gürol Canbek, and it really got me thinking about this whole idea of garbage in, garbage out.
Yeah, GIGO. It's one of those things, it's such a fundamental concept, but it's amazing how often it's overlooked. Especially in machine learning, right? We can build these really complex algorithms, but
It's like you can have the best blender in the world,
yeah,
but if you're putting in like spoiled fruit, your smoothie's not going to be good.
exactly. It doesn't matter how fancy your blender is. Bad ingredients equal a bad smoothie. And it's the same with data and algorithms.
So true. And this paper, it kind of hit me with that in a new way. It's focused on classifying things,
hmm
and they use the example of cybersecurity, like figuring out if an app is malicious. But what I thought was so interesting is that this approach can apply to so many other things, right? It's not just about apps.
Absolutely. I think what Canbeck does really well is he shines a light on data quality because that's often, not as glamorous maybe as building the algorithms themselves. He digs into a method for analyzing what he calls feature space distribution.
Okay. Feature space distribution. So for those of us who aren't swimming in data all day, what does that even mean?
So think about an app on your phone. Every app you use asks for certain permissions, right? Like it wants to use your camera or see your
Yeah,
location.
I would get those pop-ups.
Right, exactly. So imagine you're looking at tons of these apps, thousands, even millions. This method basically analyzes how often specific permissions are requested across all those apps. So it's like creating a fingerprint almost for each app just based on its permission requests.
Okay, so we're building a profile of an app, kind of, just based on what it's asking to access.
Yeah.
Got it. But how does that help us figure out if the data itself is good or not? That's kind of the garbage in part we're trying to figure out.
Right. Right. And that's where it gets really cool. What Canebick found is that these fingerprints, these patterns of app permissions, they often resemble patterns we see in other areas completely. We're talking like natural phenomena.
Wait, hold on. You're telling me there's a connection between like an app asking to see my contacts and like, I don't know, earthquakes?
It sounds crazy, right? But the patterns are surprisingly similar. Think about earthquake frequency. You have a lot of small earthquakes that happen, pretty often, and then fewer medium-sized ones, and then even fewer really huge, devastating earthquakes, right?
Okay, yeah, that makes sense. So this fingerprint idea, it's not just about spotting bad apps, is it? It seems like this could apply to like how we look at all data, right?
Exactly. It's about understanding that data has these inherent characteristics, almost like a personality. And so just like you wouldn't expect a shy person to suddenly become the life of the party, we shouldn't expect a data set with a certain fingerprint to behave like one with a totally different pattern.
Okay, that's a cool way to think about it.
Yeah.
So let's say like I'm working on a machine learning project, right? How can I actually use this fingerprint idea?
Well, it starts with visualization. Create a graph or a visual representation of your data that shows how often each feature appears. So in the app example, that was those permissions, right?
Right, right. So if I'm looking at, say, data from, I don't know, like an online store, a feature could be products viewed or like time spent on a page, that kind of thing.
Yeah, exactly. You got it. Plot how often each of those things occurs in your data. And then you compare that distribution, that shape, to known patterns. Some common ones you might have heard of, like the bell curve.
Yeah, the bell curve.
But there's also things like the power law or Poisson distribution.
Okay, so like I make my graph, my visualization,
Mhm.
and it actually does look like one of these patterns. What then?
Then context is key. So compare what you're seeing to other data sets in a similar field. Are there any big differences? Because if so, that could point to something funky with your data, or it might just highlight something unique that needs more digging.
So even if my data seems to fit a common pattern, like the bell curve or whatever, it doesn't automatically mean everything's perfect.
Right. You still got to do your homework. Compare it to the bigger picture.
Interesting.
And that's what I think is so cool about this whole approach. It's not about like blindly trusting the data, right? It's about understanding the data's nuances, its limitations even, so you can then draw better conclusions from it.
It's like that saying, all that glitters is not gold.
Yeah.
Just because data looks good on the surface doesn't mean it's automatically reliable,
Yes,
right?
yes, exactly. And this is where Canbeck's research gets even cooler, I think. Because he doesn't just stop at looking at the features that fit those common distributions, those common patterns. He also looks at the outliers, the stuff that breaks the mold.
The rebels of the data world.
Yeah, you could say that. And a lot of times, those outliers, they're super valuable. They can reveal hidden relationships or really unique characteristics in your data that you wouldn't have even noticed otherwise.
It's like you're walking through a field of daisies.
Right.
Right. And then suddenly, boom, there's this like rare orchid or something. It stands out, and it might just hold the key
Yeah.
to some whole new discovery.
Exactly. It's like in Canbeck's study, he found some permissions that were rarely requested by those, harmless apps, but they popped up way more in the malicious ones. And that kind of insight is huge, especially for something like cybersecurity, right?
So it's not always about getting rid of the outliers, those weird data points. Sometimes it's about figuring out what they're trying to tell us. Huh. This is really making me think differently about data. Wow, this has been really eye-opening, actually. Makes you think about data differently. It's not just like numbers on a screen.
It's true. Data's got a story to tell, right?
Totally. Like all those numbers,
Absolutely.
they're painting a picture. But we've got to be careful because sometimes those pictures can be misleading.
Absolutely. And it's our job to kind of become detectives, right?
Mm.
Learn how to spot the clues, figure out if the data's telling us the whole story or just part of it.
Exactly. And this is what I think is so important about Canbeck's work. He's giving us new tools to do exactly that. But, we've been talking a lot about apps and cybersecurity. But what does this all mean for, like, the average person, someone who's not, a data scientist or a programmer?
It's a great point because we live in a world that's just like drenched in algorithms, right? I mean, everything we do online pretty much is shaped by them.
Yeah, it's true. From the stuff we see on social media to, like, even what movies Netflix recommends.
Exactly. And so much of it, we just take it for granted, right? We
Yeah.
assume these systems are working correctly.
And I guess most of the time they probably are. But what happens when they're not?
Right. And that's the thing about garbage in, garbage out, right? If those algorithms are being fed bad data, biased data, incomplete data, well, then the results are going to be messed up too.
And that can have real consequences, can it?
Oh, absolutely. It can affect everything. Like, think about loan applications or job recommendations.
It's kind of scary when you think about it.
Yeah, it is, which is why this whole conversation about data quality is so important. It's not just a tech issue, it's a societal issue. We all need to be more aware of it.
So it's about being informed, right?
Yeah.
Like questioning the information we're being given, not just blindly trusting that some algorithm has everything figured out.
Exactly. Ask questions. Where'd this data come from? Who collected it? Is there anything missing from the picture?
Don't be afraid to think for yourself.
Yeah. I love that. It's like, yeah, algorithms are powerful, but we don't have to be powerless.
Well said. Well, on that note, I think we've done a pretty good job of unpacking this whole garbage in, garbage out thing.
I think so too. It's a complex issue, but hopefully we've shed a little light on it.
I think we have. And hey, maybe we've even inspired a few people to go out there and examine the data they're seeing in a whole new way.
That would be awesome.
It would. All right, folks. That's a wrap for today's deep dive. Until next time, stay curious.